This video is about bracing. We'll start by looking at a small PowerPoint about some bracing issues. So the reason why we need bracing is to support these foundations of structures. Okay, without these supports, then we have houses collapsing. Okay, so there's an example of some framing that will be bracing. And here's an example of one that doesn't have bracing and what can happen. Okay, so to stop it moving side by side, we can use bracing. There's an example of a really long brace. A bracing going up buildings. And remember when you had braces as a kid, okay, it's to stop movement. So the bracing material, either timber or steel, okay, typically diagonally. We've got these two ideas of tension and compression. So this supporting diagonal piece of timber or steel is either going to be stretched out or squished together, depending on where the movement is on the wall. Okay, and hopefully it supports it well. Here's the important part. Ideal angle is 45 degrees, but we'll accept anything between 37 and 53. Okay, anything less than 37 would say, no, that's not okay to brace that way, and we'll have to redesign. So that was a pretty good PowerPoint, wasn't it? All right, so we'll have a look at some problems. Okay, so make sure that you underline or highlight this component. Okay, what's the longest brace that could be used on this frame? So we've got 2800 high, 5100 long. And we want to know what's the longest possible brace. So how far could this brace possibly be? Okay, so doing these sorts of problems, need to obviously observe the rule that it needs to be between 37 and 53 degrees. Okay, I'm going to make, in this case, the angle as small as possible. I'm going to make the angle 37 degrees because I know any bigger angle, this brace would be smaller than the one at 37 degrees. Okay, so the longest brace will be at that 37 degree angle. I can draw a little right angle triangle. This height is 2800. Okay, I need to find the length of the brace. Okay, I need to find the hypotenuse. So I'll draw just a little sketch diagram of what this should look like. I'll look at this diagram and I'll realize that I should use sine because I've got the opposite and the hypotenuse. And I'll just go about my business. Use sine. So sine of the angle is opposite over hypotenuse. Sine of 37 is 2800 over the hypotenuse, which is x. Okay, remember, if you're okay, you can just switch the x and the sine 37 around. Okay, I prefer to multiply both sides by x. And then divide by sine 37. Correction, yeah, sine 37. Okay, so we'll get some value here. Just type it into your calculator. Make sure your angle is in degrees in setup mode. Okay, 4652.59. Okay, remember these are in millimeters. In any sort of construction context, if there's no units, assume millimeters. Okay, so second part of the question, how long does the longest brace reach across the base of the frame? So again, I've got this brace going over at 37 degrees. Oh, before I finish, need to make sure I write a an actual statement here for my solution. The longest brace that could support this frame would be 4652.59 millimeters long. Now, how long does the longest brace reach across the base of the frame? So how far across the base of the frame does that longest brace reach? Okay, I could mark in the hypotenuse using the answer above, but I'm just going to use the height because it's an exact value, and I won't lose any detail by rounding. So again, I'll draw my triangle, 37 degrees, x 2800. I've got the opposite side and the adjacent side. Looks like I'll be using tan. Write the rule for tan. Substitute in the values that I know. Okay, and then I've got the same scenario as before. I need to multiply both sides by x. And then divide both sides by tan 37. Again, calculator time. Again, make sure that your calculator is in degrees. I'll have 3715.73 millimeters. And again, make sure we finish with the statement. The longest brace would reach 3715.73 millimeters horizontally across the base of the frame. Okay, all good. So there's two problems that we've had a look at already. Turn the page. Okay, how could the following wall be braced so that the braces cover the entire wall? Okay, so heaps of different ways we could brace this wall. Probably the way that we'd prefer to brace it would be something like this. Okay, so that we meet halfway in the middle. So essentially what we're trying to do in this problem is see whether it's possible to brace it in this manner. Okay, so down here we're essentially going to test that it is possible or allowable to brace in this manner. Okay, that is, check that the angle is between 37 degrees, yeah, and 53 degrees. Alright, need to do a little bit of work here. This height is 2800. I'm checking this angle theta, and I know this distance will be 2550. Okay, so I'll draw my diagram just so it's outside of all of that detail. Unknown angle theta, 2800 and 2550. Okay, so I've got the opposite and the adjacent side again. I'm going to use tan to find theta. Okay, again, I'll write the rule because I'm not lazy. Still don't know this angle theta. 2800 divided by 2550. That unknown angle will be inverse tan of that ratio. Okay, so I'm asking my calculator, what angle would give me this ratio that I've provided to you in brackets? And it tells me that the angle would be 47.68 degrees. Okay, so what I'd write down here is, since the angle that the brace makes with the horizontal is between 37 and 53 degrees. Okay, and I just make reference to what it actually is, 37.68 degrees. The frame can be braced in the manner shown in the diagram above. Okay, so in the next lesson there'll be a lot more problem solving around braces, but in the meantime, have a go at those problems.